All right, good evening, family. Good evening. I just wanted to make a quick video to just cover topic number 7. They will be having a test on Thursday. Tomorrow we'll be reviewing topic 7. First things first is patterns. They need to know what patterns are. They need to know what a rule is. They need to know what a number sequence is, how to extend a pattern, okay? So first things first is rule. What is a rule? A rule is just a set of instructions on what to do to continue a pattern, okay? So let's say we started with 5, right? That's your starting number. They're always going to give you a starting number, right? Your starting number. Now, they're going to ask you on the test, what are the next 5 numbers? If you use the rule, which is add 5, you're going to start with your starting number. You're adding 5 to that starting number. So 5 plus 5 is 10. 10 plus 5 is 15. 15 plus 5 is 20. And so on and so forth, right? This is called a number sequence. A number sequence is just a set of numbers, right? A number sequence, a number in front of another, okay? A pattern. A pattern, okay, is the relationship between one number and the other. From here to here, from 5 to 10, from 10 to 15. What is the relationship? What is it that I could distinguish that they have in common? What's different from them, right? So right now we have, the difference is plus 5, right? So we're adding 5 to every number. That is the pattern that I'm noticing. Now there are times where the pattern can interchange, right? The pattern could say, instead of add, it could say subtract 5. Or it could say multiply 5, okay? So in that case, you will take your starting number and you will apply the rule to that starting number and continue on the pattern, okay? There's times where it gives you a number sequence, right? A pattern, a completed pattern, sometimes completed, and they'll say, okay, let's say this is number 13, and they'll say, okay, what number in this pattern does not belong according to this rule? Okay, obviously you'll look, okay, you'll see, all right, from here to here is 5, from here to here is 3, and from here to here is another 7. So something's off here, but then again, here is 5. And they have the rule, add 5. So it doesn't make sense that this number is number 13, it should be number 15. That's just an example. Sometimes they'll give you a number sequence with a number that does not belong, and you have to figure out what number doesn't belong according to the rule that they give you. Okay, that is patterns. Divisibles. Okay, so to find out if a number, just a whole regular number, let's say 125, is divisible by 2, 5, or 10. In other words, can you divide that 125 into 2? Can you divide it into 5? Or can you divide it into 10 equal parts? It has to be equal too, no remainder, okay? So we want to find out if this number could be divided by 2, or 5, or 10. What we went over during the week, during the past few weeks, is rules. Rules and clues that you could utilize to figure out, okay, is this number divisible by 2, 5, or 10? So these are the rules here. I'm going to show you guys real quick the rules. So I had them see this and utilize this to do their work. So a number is divisible by 2, or can be divided by 2, if the number ends in 0, 2, 4, 6, or 8, okay? Ends is keyword, ends, not if the number has a 0, 2, 4, 6, 8, if it ends in a 0, 2, 4, 6, 8. And another clue is if that number is even, this number is even. Why? Right? Because it ends with an even number, right? So this whole number is even. So that's one way that you could find out if you could divide that big number into 2. Another rule is that a number is divisible by 5 if it ends in a 0 or a 5. For example, 50. 50 is divisible by 5. 55 is divisible by 5. Why? Because they end in a 0 or a 5. So that means that whatever number you're looking at can be divided into 5 equal groups if it ends in a 0 or a 5. Now, a number is divisible by 10 if it ends in a 0. So any number that ends in a 0. It could be 1 million. It could be 3,450 that ends in a 0. It could be 86,410. That is still divisible by 10 because it ends in a 0. That's the clue. That's the clue that I'm showing them. So if the number ends in 0, it could be divided by 10. So I gave them 2 examples here. I have 310 here. So according to these rules, can this number 310 be divided by 2, by 5, or by 10? And they figured out that it could actually be divided by all 3. Why? Because according to the rule, the number is divided by 2 if it ends in a 0, 2, 4, 6, 8. It definitely ends in a 0. The number could be divided by 5. It ends in a 0 or a 5. There goes that 0 again. The number could be divided by 10 if it ends in a 0. Again, ends in a 0. So 310 can be divided into all 3. Now let's look at 255. 255 only coordinates with one of these rules here. It only matches with one of these rules. And one of that rule would be that number, 255, could only be divided by 5, right? Because it ends in a 5. Now, again, there are occasions where a number like 310 can be divided into two different, numbers. It could be 2, 5, 10, or 2, 5. So depending on the number and depending on the rules. Okay, so just look at the rules and then see, okay, can this number be divided into any of these 3 here? 2, 5, or 10. Then we went on to divisible by 3 and 9. Let me see. Divisible by 3 and 9. Okay, perfect. Here we go. Divisible by 3 and 9. So to find out if a number can be divided into 3 and 9 equal parts, there's different steps here. Okay. So step number 1, you're gonna know what number are you dividing. So right now in this case, I'm dividing 371. Then step number 1, right? You're gonna add those digits. You're gonna add the digits in the big number. So 3 plus 7 plus 1. You're gonna add those, which gives me 11. Okay, that's step number 1. All right. Step number 1 is adding the digits inside that big number. So 3, 7, 1. You're gonna add them together. Step number 2, you're gonna take the answer that you got from the addition, right? But here in this case is 11, and you're gonna see if that 11 is a multiple of 3 or 9. They've been confusing the words divisible and multiple. They're 2 complete different things, okay? Divisible is if you could divide a number by another number. Multiple is if the number 11 down your 3 times tables or down your 9 times tables, do you see the number 11? Do you see the product 11 in your 9 times tables? Do you see the product 11 in your 3 times tables? Right? We're just using this 11 as an example. But so do I see number 11 in my 3 times tables? No. Do I see number 9 in my 3 times tables? No. So 11 is not a multiple of 3 nor 9. Okay? So step number 3. Then as soon as you find out that 11 is not a multiple of 3 and 9, you write, or you would think in your mind, 11 is not a multiple of 3 or 9, so 371 is not a divisible by 3 or 9. Okay? So what you're doing is you're utilizing the sum of all these digits here, figuring out if they're multiples of 3 and 9, and by you figuring out if they're multiples of 3 and 9 or not, then it lets you know that this number cannot be divided into 3 and 9. Okay? So, again, you're just using the 11 to find out if this number is divided or can be divided by 3 or 9. Okay? So that's pretty much what they're going through. Now, not all of them got this too much, so tomorrow I'm going to review again a bit more of divisibles. But that's pretty much it. Now, they are going to need to know a couple of, and composite and prime numbers. Almost forgot. Composite and prime numbers. Let me see. Okay, composite and prime numbers. So prime number is a number that only has two factors. What are factors? My factors for this multiplication problem is 5 and 4. The numbers that you use to multiply together, those are your factors. Those are your factors. The answer that you get when you multiply them is called a product. Okay? So, if a number, right? If a number, let's use another example instead of this one here. If a number is a prime number, that means that there are only two factors that you could come up with that when you multiply will give you that number. And for example, the number 2 is a prime number. There are only two numbers could come up with number 2. 1 and 2 when you multiply them. That's it. You cannot come up with any other number that will equal to 2. Okay? You could say 2 and 1 or 1 and 2, but it's still the same number, 1 and 2. Composite numbers are numbers. Composite numbers are numbers that have more than two factors. Two factors. Okay? So, again, prime numbers are numbers that have only two factors. Composite numbers have more than two factors. So, any other number, let's say number 8. Number 8, right, has 1 times 8, that's 2. Has 4 times 2, that's another 2. So we have 1, 2, 3, 4 factors that will equal to 8. Okay? Again, when you pair them, they're called factor pairs. So factor pairs are two numbers that you multiply together to get you another number. So in this case, 1 times 8 is a factor pair that will give me 8. 4 times 2 is a factor pair that will give me 8. You see how they have more than two factors. Okay? 2 would be just this, 1 and 8. But there's other numbers that you can multiply together to get you 8. So therefore, you have more than two factors. Okay? Composite has more than two factors. Prime numbers have two factors only. What are examples of prime numbers? Let's say 2, 5, 11, right? Let's see, 13. 13 is a prime number. Those are numbers that you only could get 1 times the actual number. So whatever the number is, times 1. So it's 1 and the number itself. That's it. There's only two numbers that will get you a prime number. Okay? Composite number is more than 2. More than 2. Now, 8. Okay? My basic facts for 8. I have 1 times 8. 8 times 1. 4 times 2. And 2 times 4. In the test, they're going to tell them, okay, how many ways can you grid out a number? So you're going to utilize your basic facts to grid this out. So for example, let me just do these 4 here. 1 times 8. So you have one column, just one row of 8. Okay? There you go. I just gridded that out. Now, here, you have 8 rows. So this is 1 times 8. Okay? And here, you have 8 rows. 1, 2, 3, 4, 5, 6, 7, 8. Which, with 1 in each row. Okay? 7, 8. Okay? This is 8 times 1. Now, let's grid out 4 times 2. So again, you have 4 rows. 1, 2, 3, 4, right? With 2 in each. Okay? This is 4 times 2. Now let's do it backwards. You have 2 rows with 4 in each. 1, 2, 3. Okay? This is 2 times 4. They need to know that the first number in your multiplication basic fact is going to let you draw out the rows. Rows would be up and down, the rows. The second number would be how many in each row. How many in each row. So the first number would be your rows. So you're going to counting down how many rows you're going to go across. So in this case is 8, right? Or in this case is 4. I'm going down 4. And then the second number is how many in each row. Okay? So then here I just need 2. 1, 2, 1, 2, 1, 2, 1, 2. Okay? They need to know that. So they need to know what each responsibility for each number is. So the first number is the rows. So all you gotta do is count down how many rows you need. And then the second number is how many in each row. Okay? So that's something that I want them to understand and get. But that's pretty much it, guys. See if there's anything else. Just work on the simple multiplication. 3 digits times 1 digit. 2 digits times 2 digits, right? Because they're gonna need to know how to multiply within the test. Division, knowing how to divide and making sure, even adding and subtracting. If you need to add or subtract something, just don't use don't do mental math too much. If you need to write a scrap paper, get a scrap paper. If you need to write on a scrap paper, get a scrap paper. If you need to use your fingers for now, use your fingers, just to make sure that you have the right count. Because some of you start, for example, if they say add 5 and you start at 15, some of you start with 15. You say 15, 16, and no, it's not. That's not how you move from 15. Your 15 is in the brain, right? And then you start counting 16, 17, 18, 19, 20. So you still have that issue. Some of you still have the issue of counting the actual number that you're starting with, and you don't count the number that you start with. You start from there and you start counting to the next number. Okay. Subtraction. Remember to carry over. If a number on the top is smaller than the number on the bottom, you know that you got to borrow. You got to borrow from the tens place or the hundreds place. You got 3 minus 4 or 13, let's say 23 minus 4. Then you know the 3 minus 4 you can't do. Take from the 2, okay? That 2 becomes a 1. And the 3 becomes a 13. So now you have 13 minus 4, which you could do. Okay? Always know that you have to borrow. If the number on the top is smaller than the number on the bottom, you know you have to borrow from the next place value. Let's see. That's pretty much it, guys. I think that should cover most of it. But this is pretty much what topic 7 was about. Okay? Arrays, even numbers, factor pairs. Generating, you know what generating is? It's just to produce another number, to make another number. Okay. Extend a pattern is to make the pattern longer using the rule. that's pretty much it, guys. That's pretty much it. So if you have any questions, parents, you're more than welcome to give me a call, shoot me a message, shoot me a text, whatever you guys need. I'm there for you. This is pretty simple. They got it a lot during the topic, during the lessons. They were understanding a lot of it. So I'm not too worried about it. But yeah, we'll be all right, guys. All right. Have a great day. Bye-bye.